Okay, so back to our general periodic table. Remember, the far left side, we have 2 columns, 6 columns, 10 columns, 14 columns. And if we divide those by 2, we get 1, 3, 5, and 7. So this part of the periodic table that has 2 columns, we divide 2 by 2, we get 1, which was the number of orientations for s orbitals. So this part of the periodic table we call the s block. 3 orientations are for p orbitals, so this part of the table is called the p block. 5 orientations matches d orbitals, so this is the d block of the table. And 7 orientations matches the f block. So we have S, P, D, and F blocks of the periodic table. Every time we drop down a row in the periodic table, we increase the quantum number n by 1 value. So if I re-sketch this out, the very first row in the S block is, remember, S's, we start at number 1. So this would be the 1s. That's where we're going to start that. That 1s has 2 quantum numbers. The 1 is equal to the n value, and the L value, because it's an s orbital, we know that that stands for the quantum number L being 0. If we drop down a row, the only thing that changes is the number. Instead of 1s, this is going to be called the 2s. These are called subshells. So we can continue. We have 1s, 2s, 3s, and so on. If we're over in the p block of the table, the first p is not 1p because we start the p's at number 2. So this would be the 2p subshell. And then if we drop down a row, we'll be talking about the 3p subshell. And another row, we're in the 4p subshell, and so on. The d's start at number 3, so this would be 3d. We drop down a row, and now we have 4d, and so on. The F's block is found down here, and F's start at number 4, so the first row in the F block is 4F, and then the row underneath that would be 5F.